Okay, so our last chapter for this course will be a bunch of examples. Um, the first example we're going to consider is a family of examples where we add a root of a quadratic. So let's let k be a field, and we're going to consider the polynomial f of t is t squared minus q in k join t. All that means is that q is in k. All right. Then we can look at the splitting field of that polynomial. So what should the splitting field be? Well, if we add in the square root of q, we'll get minus the square root of q as well. And so this will be the splitting field of f. All right. Now the degree of this extension is certainly 2, right? It's a quadratic extension. So, and we have a splitting field, so the Galois group of L over K also has order, the degree, by the fundamental theorem, which is 2. And we also know that, well, we have the identity element, but there's also, I guess it's not a but, the non-identity element. Let's call it sigma, negates the square root of q. In this setup. So what am I trying to say here? Sigma of a plus b root q will be, of course, a minus b root q. Now, I didn't mention here, but I suppose this is assuming that the square root of q is not in k. Of course, if the square root of q is in k, then L is just k, right? And so there's no, this is a trivial extension, and the Galois group is therefore trivial. This just has the identity in it. In this case, the Galois group is identity and sigma, which is, I know there's a lot of different ways of writing it. It's S2, or it's Z mod 2, or it's mu2, however you like to think about it. Okay, so what are some examples of this? Well, of course, some of the extensions that we've seen, for example, q adjoin the square root of 5 over q, we know that the square root of 5 is not a rational number, so the Galois group is Z mod 2. I'm going to choose to write it that way. The Galois group of, let's say, q adjoin I over q is Z mod 2. The Galois group of q adjoin, I don't know, like 1 plus I over q adjoin I. Of course, 1 plus I guess that's not really a quadratic. Let me take that back. Let's see. A quadratic where we add the square root of something and it's already there is escaping me. I guess we could do something like q adjoin the square root of 4 over q. Of course, the square root of 4 is already there, so this is just the trivial group, which is often written as a 1. So these are the simplest types of extensions. If the square root is in our field, then it's trivial. So the Galois group is trivial. Otherwise, we get Z mod 2 as the Galois group. So here's our first example.